Alright, welcome everybody to part 2 of our trust video. Now, tragedy struck and my screen recorder did not save. I've actually already recorded this video, so I copied down my notes again to get myself a blank page. So if you're wondering why things look slightly different or why maybe this is the next day, movie magic, you won't even notice. But we're going to dive back into this problem. We are on step 5, looking for a single unknown force in either the X or Y direction at a single joint to solve for it. So I like to start at joint A and ask myself, are there two unknowns, or is there one unknown, or are there more unknowns in the X direction? Well, I count 1, 2 variables still in the X direction, so I can't do anything with that. However, in the Y direction, FABY is my only unknown. So I know that FABY must be equal to 119. And since this 119 coming from RAY is pushing up, I know that FABY must be pointed down so that it is balanced out. That tells me a lot of information. For one thing, if we think back, if I have a joint pulling away, that's called tension. And if it's pushing in, that's called compression. Therefore, member FAB must be in compression since this arrow is pointed towards the joint. So if I come up here, I can show that on my initial free body diagram. I can also take every member that has AB in the name and I can push it in. And look, there's FABY again. So that's 119. Okay. So that tells me a lot. Now, let me look at joint B. Well, let's see. In the X direction, I've got 1, 2 unknowns. In the Y direction, I only have one unknown, FBCY. So I have 50 going down, so we could say sum of all our Y forces at joint B equals 119 going up, 50 going down, plus FBCY, and that's all got to be equal to 0. So you do a little calculation. FBCY is equal to 50 minus 119, which should get you negative 69, which is going to be 69 also pulling down. So that tells us something too. Member FBC is in tension. So I can go ahead and shade in these arrows up here. Oops. Make sure you can see that. Okay. Then everywhere I see a member FBC, let me get my camera a little bit closer here. Oh, that's much better. Focus it in. Everywhere I have member FBC, I can put that into tension. Hey, look, that's FBCY. I already solved for that. 69. And look how much sense that makes. I got 69 going down here. Must have 69 going up here. FBCX, so that's going to be in tension as well. Alright, so now I look at joint C. I ask myself, how many unknowns are there in the X direction? Well, I've got 1 and 2. I still got 2 unknowns here at B and 2 unknowns there at A. All my Y forces are solved for, so it looks like I'm stuck. So I'm going to have to come down here to step 6. If you get stuck, use trigonometry to find an X or Y force using the other component and the angle from the truss diagram. So let's use our FABY, which is 119. So I can draw a side length in the Y direction, that's 119. I have a side length in the X direction called FABX. And this is eventually going to be member FB. And if I go back to my truss diagram right here, I can find that angle is 52.1 degrees. Now, I'm looking at the relationship between this, which is FABY. That's the opposite to the angle, and FABX is the adjacent side to the angle. So opposite and adjacent, I'm going to use tangent. So tangent of 52.1 equals opposite, 119, over FABX. A little bit of algebra will get you FABX is equal to 119 divided by the tangent of 52.1. Punch that into your calculator. And you get 92. Well, let's stick with our whole numbers here. 93 pounds. All right, so FABY is 93 pounds. So what does that tell me up here? Well, or sorry, FABX is 93. Okay. Well, if FABX is 93, there's a few things that can tell me. For one, look at joint A now. I've only got one unknown in the x direction. So I can sum up my x forces at joint A. It's an x. All right. And I've got 100 pushing to the right. That's going to be positive. I've got 93 pushing to the left. It's going to be negative. And I've got FAC, and all that must be equal to 0. So you end up with FAC is equal to 93 minus 100, which is negative 7. So that must be 7 pushing to the left. That means member FAC is in compression, and it's only worth 7 pounds. Since member FAC is perfectly flat, it's not going to have component vectors. I've already solved for it. So FAC, I can also see right here, is 7. Now, that actually tells me something very important over here at joint C. I've got 7 pushing to the right. My only other x force is BCX, so that must be equal to 7 pushing to the left. And I can fill that in over here as well. All right, we're actually done. We solved for all of our component forces. All right. Now, we're going to move on to the final step, which is final 2 steps, which is combining our forces to find our actual member forces. So everything we found so far, except for FAC, has been a component force. So remember, FAC is 7 pounds, and since it doesn't have components, I actually already know, and I also know that it's in compression. I can note that there. All right, but FAB, we're going to have to solve for. So it has a right triangle. Here, this is FAB. This is FABX. This is FABY. Remember, FABX is 93. FABY is 119. I think it's a good time to zoom the camera out a little bit. There we go. Rearrange. All right, so now I'm just using Pythagorean theorem to solve for FAB. So I've got 93 squared plus 119 squared. Take my square root of that number. 151 pounds. And I believe we found that FAB was in compression. Last one is FBC. It's got an X, it's got a Y. FBCX is 7, FBCY is 69. So I can punch those in. Pythagorean theorem. 7 squared plus 69 squared. Square root of that answer. It's going to be really close to 69. 69.4. We'll just keep rounding. And that's in tension. So for our final step, we're going to redraw our truss. Get a nice sketch of it here. Here's A, here's B, here's C. We can put in our reaction forces. Go all the way back to look at this here. RAX is 100, RAY is 119. Make sure, yep, there we go. And this is 69 going down. There's some applied forces up here, 50, 100. Then we fill in these. So I've got 151 pounds of compression along this member, 7 pounds of compression here, and 69 pounds of tension there. And that's your answer. Well done. You did it.